Today we're going to look at using rational or your rules of exponents to simplify expressions that contain rational exponents. So first, let's go ahead and review what a rational exponent is. A rational exponent is just a way to rewrite the power and the index of the root that you are taking. So for instance, if we simplify -8 raised to the 4/3 power, that is the same as writing the cube root of -8, and remember the negative is inside the parentheses, so it goes under the radical, all raised to the 4th power. So I know the cube root of -8 because if I factor -8, I get a -1 times 2 times 2 times 2 raised to the 4th power. The cube root of -1 is -1, and I have a group of 3. So I get -2 raised to the 4th power, and if I multiply -2 4 times, I get 16. My next example has the negative outside of parentheses. There are no parentheses, so the assumption is that your problem looks like this. When we convert to radical form, the negative goes outside of the radical. We have a square root this time, the square root of 9, and we're going to raise that to the power of 3. So I know that if I factor 9 factors into 3 times 3, and I have my group of 2, because I'm looking for groups of 2. The square root of 9 then is -3 cubed. And remember, the exponent is only being applied to what it's next to. So it's next to the 3, not a -3. So the exponent of 3 is being applied to the base of 3 only. So I know my answer is going to be negative, and 3 cubed is 27. So that's how you work those two different types of problems. So now what we're going to do is we're going to start using our rules of exponents to simplify the following. We have a negative exponent rule that says a to the -m equals 1 over a to the m. And we have 1 over a to the -m equals a to the m. So what we're doing here is we're just taking the reciprocal of the base. So here's the base. It's in our denominator. So when we take the reciprocal, we're going to move our base up to the numerator. So remember, we're just switching positions. If something in the numerator has a negative exponent, you move it to the denominator. If something in the denominator has a negative exponent, you move it to the numerator. So when I move it to the numerator, I get x to the 5/3 over 1, and I don't really need the over 1 because when you divide by 1, it's the same thing. So in this case, I'm using my rules of exponents to simplify. Here I have two bases that are exactly the same, and in this case, I'm going to go ahead and use my product rule, and my product rule is if I multiply a to the m by a to the n, I can just add my exponents. Okay, they have to have the same base though. All right, so we're just going to add these exponents. Y to the -7/3 plus 16/3 equals y to the 9/3, and we know that we can reduce 9/3 to 3, y cubed. So when I simplify that expression, I get y cubed. In my next example, we're dividing m to the 1/7 by m to the 1/21 power. And so because we're dividing, I'm going to go ahead and use my quotient rule. My quotient rule, remember, is if I have a to the m over a to the n, I subtract exponents. Okay, it's numerator exponent minus denominator exponent. And again, the bases must be the same. So my bases are the same here. They're both m. So I'm going to subtract their exponents. M to the 1/7 minus 1 over 21. And now I'm going to need a common denominator. So I'm going to use the denominator of 21. So this is going to be m to the 3 over 21 minus 1 over 21, which is equal to m to the 2 over 21. So you should go ahead and on your homework, you should match up problems that are similar to these and work them the way I did. I don't want you converting to radical form. I want you to apply your rules of exponents. So let's move on to the next set of examples. Here we're going to be using our power rule. And remember, our power rule says that if we have anything in parentheses, whatever it is, and we're raising it, a to the m, raised to the power of n, what do we do with that power? Those powers? We multiply them, a to the mn. All right, so in the first example, we have a power, and we always need to work our power rule first. So in our power rule, we have 3/2, and inside parentheses, we have x to the 3rd power. So this is going to be x to the 3 times 3/2 over x to the 13/2. When I multiply 3 times 3/2, I get x to the 9/2 over x to the 13/2. I know if I use my quotient rule, I just subtract exponents. So when I use my quotient rule, I get 9/2, or x to the 9/2 minus 13/2, which is x to the negative 4/2, which reduces to x to the negative 2. But I can't leave negative exponents in my answer, so I am going to convert this to something with a positive exponent. So I'm going to use my negative exponent rule and move the x from the numerator to the denominator and convert the exponent to a positive. All right, so how do you work something with a number in it? Well, I want you to remember that everything in your parentheses has an exponent, even if it's not explicitly written. So I'm going to add an exponent of 1, which means I have to multiply the 1 by the 3/2 and the 3 by the 3/2. So I get 9 to the 1 times 3/2 and t to the 3 times 3/2. When I multiply the 1 by the 3/2, I get 9 to the 3/2, t to the 9/2. And now I notice that I have a number. So I really need to convert to radical form, just the number, not the variable, to see if it reduces. If it doesn't reduce, then we're finished. But if it does reduce, I need to continue to simplify. So when I convert the 9 to the 3/2 to a radical, I get the square root of 9 raised to the 3rd power, which is, what's the square root of 9? 9 is 3 times 3, and I'm looking for groups of 2. So I'm going to circle those. So that is going to be 3 cubed, which is 27. So I'm going to replace 9 to the 3/2 with 27t to the 9/2. And that is my final answer. Now my last one, I have a couple of things going here. I've got a number on the inside, and I've got 2 different variables, so I'm going to have to multiply all of these exponents by 3/4. And then in the denominator, I also have exponents on the inside of my parentheses, and I'm going to have to multiply those by negative 1/2. So when I go ahead and start multiplying, I get 16 to the 3/4. When I multiply 3/4 by 3, I get 9/4. And when I multiply 5 times 3/4, I get b to the 15/4. And now I'm going to work on my denominator. I'm going to multiply negative 5 times negative 1/2 to get a positive 5/2. And then I'm going to multiply b raised to the negative 2. So negative 2 times negative 1/2 is a positive 2/2 or a positive 1. So I have a couple of things that I have to do. I notice I have variables that have the same base, both in my numerator and denominator. And then I also have a number being raised to an exponent. So I'm going to go ahead and reduce my number first. I'm going to take 16 and reduce it and see if it simplifies. So I'm taking the fourth root of 16 and then raising that to the power of 3. Well, the fourth root of 16, let's see, if I factor 16, I get 2 times 2 times 2 times 2, and I'm raising that to the power of 3. So I'm circling groups of 4 numbers that are the same. So I get 2 cubed, and I know 2 cubed is 8. So 16 to the 3/4 reduces to 8. But I now also have to use my quotient rule. So I'm going to use my quotient rule and figure out what this all equals. So I know I'm going to replace 16 to the 3/4 with 8. And for A, I'm going to take 9/4 minus 5/2. And B is going to be 15/4 minus 1. So I really need a common denominator. And that denominator for A is going to be 4. So I get 9/4 minus, let's see, 9/4 minus 10/4, and B is going to be 15/4 minus 4/4. I'm going to move that up a little. And when I finish, I'm going to get 8a to the negative 1/4, b to the 11, oh, that's a 4, 11/4, which is simply going to be 8b to the 11/4 and a over a to the 1/4, because I need to write my answers with all positive exponents. All right, so let's move on to the last set of examples. Here they're asking me to multiply. So I'm going to use my distributive property and multiply. I again am going to use my rules of exponents to simplify. So I'm going to distribute this p to the 1/3, and I get p to the 1/3 times p to the 2/3 plus 5p to the 1/3 times p to the 8/3. And I notice when I'm multiplying, I should be using my product property, which tells me to add exponents. So I'm going to add those exponents to simplify. P to the 1/3 plus 2/3 plus 5p to the 1/3 plus 8/3, which gives me p to the 3/3 plus 5p to the 9/3. And I know those fractional exponents reduce. So I get p to the first plus 5p cubed. These are not like terms because my variable with its exponent is not the same in both terms, so I'm finished. So for this one, I'm going to distribute a binomial across a binomial. That's called foiling. So I'm going to get, when I do 2x to the 1/4 times 2x to the 1/4, I need to make sure that I multiply my 2's. And then when I multiply across the -5, I get minus 10x to the 1/4. And then when I distribute my +5, I get plus 10x to the 1/4. And then 5 times -5 is -25. When I simplify this first term, remember I'm adding exponents. I'm using my product property. So x to the 1/4 plus 1/4. The -10x to the 1/4 plus 10x to the 1/4, they are like terms and they cancel out. Minus 25. So when I add 1/4 and 1/4, I get x to the 2/4 minus 25. And I know that 2/4 reduces to 1/2 minus 25. They are not like terms, so I cannot combine them. So that is my final answer. All of the work on your worksheet should be done similar to that.